Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at subject database management system. Today's session will be continuation of the previous session, where during the previous discussion we had introductory discussions on data mining. Now we will try explaining the different processes that we handled during the phases of data mining. So, I still continue with the same learning objectives where we try to understand the need for data mining, databases and data mining tasks. So, our discussions will be preliminary on the different data mining tasks that we perform. If you closely watch at the previous discussion, on the last part of the discussion we have studied on the decisions made during data mining phase, and we have tried explaining the different data mining tasks. So, we were trying to discuss on how databases and knowledge differ, or what makes it different from a regular data to a knowledge. So, in order to extract more of a knowledge, we may have to categorize or characterize data, discriminate data, associate, classify, cluster, trend, deviate and outlier analysis are also to be performed as part of knowledge discovery. But on top of this, for several databases and data warehouses, we tend to apply our techniques like database oriented techniques, we have data warehouse techniques, machine learning techniques, statistical techniques, visualization, neural network, Bayesian model techniques are also available as part of the decision making models. Further, the different applications for which we can adapt this data mining model to are retails or retail industry, telecommunication, banking, fraud analysis, DNA mining, stock market analysis, web mining, web log analysis, etc. During our later discussions, we will try seeing how we can extract information from these data set, at least one of the data sets, say retail data set, what kind of data could be, or what are the data which are hidden and what could be predicted can be majorly seen. So, as I have told you during the previous discussion, there are two different data mining tasks which are predictive task and descriptive task. If you look at predictive task, they use some variables to predict unknown or future values of other variables, whereas description tasks find human interpretable patterns that describe the data. So, any pattern that human mind can generate and interpret, those will be of more of prediction tasks. But by use of tools, it is not just in a human interpretable format, but then we tend to predict what would happen without knowing the previous occurrences of its values, or by knowing the previous occurrences of its values. So, some of the very common data mining tasks include classification, which is part of predictive data mining, clustering, which will be descriptive data mining, association rule discovery, where we might write rules on finding out a certain pattern which will be of descriptive type, sequential pattern discovery will also be of descriptive data mining, regression, which will be of predictive mining format, deviation detection, which will be of predictive mining format. So, as I have told you, data mining broadly classified into predictive data mining task and descriptive data mining. With predictive, we have classification, regression, time series analysis and prediction, whereas with respect to descriptive, we have clustering, summarization, association and sequence discovery. So, these are the two different formats that we are about to look at in the shortcoming discussions. As we have told on the association rule mining, we will try to extract how these patterns are discovered with a simple example. These association rules majorly contribute from a general study called market basket analysis, which is part of retail industry. So this market basket analysis tends to analyze on the customer purchase behavior. So this is a shopping cart where I tend to purchase different items. What will be the possible set of combinations that I tend to buy can be or should be analyzed, thereby we derive a pattern relating to it. So association rules are nothing but we write a rule, say typically in a form of when a person buys cheese and milk, what is the proposition that, or what is the truth that he will also buy bread along with these two things. So these, after having written this rule, to understand this rule in better or to understand the worthiness of this rule, we have two very interestingness measures which are associated with this rule format. So this is like A comma B implies C. We will try understanding the interestingness measure of these two rules, which are given by support and confidence. I generally say that 80% of the customers who buy cheese and milk also buy bread. So 80% of the people who buy cheese and milk also buys bread, so the confidence becomes 80%. And 5% of customers buy all of them together. So all the three things will be put together, will be bought only by 5% of the crowd. So this gives us a clear discrimination of discovering patterns, thereby projecting some valid information, hidden information in the needed format as required by the retailer industry. As I have clearly discriminated on several data mining tasks based on descriptive and predictive, we will try initially looking at the basics of those data mining tasks. If you look at classification as one of the data mining tasks, classification is nothing but we try mining patterns that can classify future data into known classes. So we almost would have defined some known classes. Say for example, when you write an examination, there is a possibility that your grading might be done on any one of the previously defined grade lists, say O which corresponds to 90 and above, S which corresponds to 80 and above. Likewise, I have predefined classes and my mark will go and sit on any one of this class. So that is your classification. The other data mining task is association rule mining, which is nothing but mining any rule of the form X implies Y, where X and Y are the set of data items. As we have seen in the previous example, when a customer tends to purchase cheese and milk, what is the prediction or what is the importance that the same customer will buy bread? So we tend to write it like a rule, so which we now call it as association rules, which will be combination of multiple data items. And the third important category which is part of this data mining task is clustering, whereby we tend to identify a set of similar groups in the data. So by clustering, we tend to analyze similar patterns. So this is based out of unsupervised learning, whereas classification is supposed to be a supervised learning class. Sequential pattern mining writes sequential rule A implies B, where it says that event A will be immediately followed by event B with a certain confidence. Not only that, we have some more data mining tasks which are associated with it, like deviation detection, which tries to discover most significant changes in data. Anything that is deviating from the routine of the work, we also tend to detect those routine values. Say in case if I have got a cluster and I assume that these data values can never sit on those cluster, why these data values are deviated can also be made a study. So and further we have a visualization, data visualization, which is a graphical method to show patterns in data. Like I tend to connect multiple personalities across different parts of the country on a common medium. So as we have seen, data mining has another name which is called knowledge discovery in databases, where this data mining is actually being carried out as a process where it first tries to understand the application domain, the domain for which this process need to be applied. Then it tries to identify the different data sources and selects the target data. The input and the output in what format is required is tend to be analyzed here. Not only that, in order to take it to the required target, we may have to pre-process on the data. So what we do is, as a part of pre-processing, we do cleaning, attribute selection and and we will try to explain this individual task in detail. Not only that, data mining is also used to extract patterns or models. And as we have done a pre-processing, we may have to parallelly perform a post-processing where we may have to identify interesting and useful patterns, or interesting or useful patterns, which can be fetched very well, received very well by the customers. So incorporate patterns in the real world task. So try applying it directly to the application, which might fetch you with very good results. Like as we have seen before, we are trying to replicate some of the important applications for which data mining has proven to be very effective are for marketing, customer profiling and retention, identifying potential customers, customer segmentation or market segmentation. Not only that, the same data mining can be applied to fraud detection, whereby we can identify credit card frauds and we can in turn process on intrusion detection systems also. Further, initial discussions on data mining, we have looked at scientific data analysis, whereby we can present it in visualization formats. We in turn can use this data mining for text and web based applications also. Not only that, this data mining can be applied to any applications that involve large amount of data. So if at all there is supposed to be a large volume of data, we can apply data mining techniques, and this process might fetch you a lot of knowledge rather than presenting it just as a data. Having looked at individual terms of how to get an input and what sort we may have to present the output of different sorts, let us try to understand how these pre-processing is being done as part of this data mining. As a first level of pre-processing, we will try cleansing the data or cleaning the data, where we fill in missing values. Any missing values that are presented in the data cube, we will try filling up all the missing values. And if there are noisy data that is available as part of this data cube, that can also be, I cannot say it can be completely avoided or eliminated, but then it can be smoothed. We can identify or remove the outliers. So we will try extending this discussion to identify what the outliers are. So we can try identifying and removing the outliers which are part of the data clusters, and resolve inconsistencies. Say for example, a person who is named Sendil would have been stored in 3 different data variants, 3 different data instances, but then it is all referring to the same person, but then I am trying to create 3 instances with different spellings. So these inconsistency can also be resolved, and this is part of data cleansing process. And the second of the pre-processing stage would be on data integration, where any data which tries to enter into the data warehouse from heterogeneous data sources, that is, I am trying to integrate from multiple data sources, data cubes or files, are to be effectively transformed to the needed data format, and all the integrated data need to be transformed so that the data out of the transformed data values need to be normalized and aggregated. Further, this data warehouse or the pre-processing stage might look bit heavier. So, we might go for a data reduction phase where it obtains reduced representation in volume, but produces the same or similar analytical results. And further, we have data discretization, which has a part of data reduction, but with particular importance especially for numerical data. So, these are some of the pre-processing strategies that we tend to do before actually taking it to the data mining phase. But why am I to process with the data? What happens in case if I do not do a pre-processing? Data that enters from heterogeneous data sets will be majorly dirty. Dirty means it will be mostly of incomplete formats. So, it lack attribute values. Say some of the attribute values might be missing and it lacks certain attributes of interest. Any attribute that is essential for that particular construction might have been missed out or containing only aggregate data. More effectively, the data which are presented in the database tables are likely to be noisy. That means it might contain lot of errors and outliers. And further, this data may be inconsistent, so containing discrepancies in the codes or names. So, in case if the data is being presented in a dirty format, then the resultant cannot be effective. So, what we are expecting as an output from the data mining phase would be on an effective result. This effectiveness might be lost. So, when we do not have a quality data, then we cannot expect quality mining results. So, quality decisions must be based on quality data. Data warehouse needs consistent integration of quality data. So, that was the reason why we actually gone through a phase of pre-processing. As we have seen to the first stage, which is called data cleansing phase. During the process of cleansing, several tasks has been done to fill in missing values, to identify the outliers and to smooth out noisy data, and basically to correct inconsistent data. Say for example, if I try to import data, then I merge from different data sets, rebuild the missing data, standardize data, normalize it, deduplicate it, verify with the actual database whether this is essential to be converted as a knowledge, and finally we tend to export the data. So, this cleansing phase actually goes through a sequence of process by where we tend to avoid missing values, we tend to identify and avoid outliers, and we majorly smooth out all the noisy data, and we correct inconsistent data also. During the phase of data mining, one of the major drawback during the phase of pre-processing we find is on the missing data. We could try replacing those missing values as part of this database or data warehouse table. So, data is not always available. For example, many tables have no recorded value for several attributes. So, whatever values that we might need, if at all we wanted to add an attribute to it, many tables might not give a complete list of attributes. Say we might need customer income in sales data. So, sales data does not involve customer income. In that specific detail, in that specific juncture, we can take this customer income towards this sales data, and which might help in predicting the customer behavior. So, people who are earning between say 40,000 and 50,000 are most likely to buy a laptop. So, that conclusion can be drawn from the sales department only by looking at the customer's income. So, people who largely go for higher versions of the laptop, say if at all we wanted to buy a laptop without major of a risk, who are the people who will buy laptops can be easily understood by a salesperson by connecting it with the customer income data. So, we tend to take these attributes to the other table so that the analysis becomes more perfect. Some of the missing data may be due to equipment malfunction. So, sometimes the equipment would have been there would have been a malfunction in the equipment which might lead to unnecessary miss of some of the data. Inconsistent with other recorded data and thus deleted. So, there might be inconsistencies with the other data, because of that some of the data would have been deleted. Data not entered due to misunderstanding. Certain data may not be considered important at the time of entry. So, some of the data may not be important at the time of entry. Say for example, during the phase of Aadhaar entry, if we are given with an option of editing at any time, we may not fill most of the columns, but having to be entered at the same point in time, we may have to verify all the details very perfectly relating to the person who is taking the Aadhaar, the name should be checked, the date of birth should be checked, the address is also to be verified. So, there can be a possibility that some of the values might be missed. When taken a hard copy, we might replicate saying that these values are missed. Not register history or changes of the data. So, missing data may need to be inferred. So, we may have to actually infer on the actual data values, which might help us in order to effectively frame on the result. But then now we are trying to understand on the missing data. So, how to handle missing data. So, between two different people who are working on the missing values, appropriate values need to be fetched is the basic understanding we try to get in from the figure. We try filling in the missing values manually, which might be tedious. So, we are not actually processing with databases, please remind of yourself. We are going for a data warehouse wherein large volume of data, say in terms of GBs per hour, might be loaded into the database. So, entering all the missing values to that becomes not very much feasible. So, this becomes tedious and infeasible. Use a global constant to fill in the missing value. Say for example, we have a constant value called either null or null is majorly not been accepted, we can type it as unknown. So, which is tend to be a new class that could be replaced instead of null values. Use the attribute mean to fill in the missing value. Use the attribute mean for all samples belonging to the same class to fill in the missing value. That becomes a smarter approach. Use the most probable value to fill in the missing value, like inference based such as Bayesian formula or decision tree. These two we will look at very shortly, but then in order to look at the more probable value, we might have to have some of the techniques like Bayesian formula, understanding and decision tree, wherefrom we can generate some values and we can fill on those missing value details. So, we have studied mostly on the missing data values. Now, we will tend to understand on the noisy data. So, by noise I tend to say project more on the random error or variance in a measured variable. So, these will be mostly of incorrect attribute values, and this may be due to faulty data collection instruments, data entry problems, data transmission problems, technology limitation, inconsistency in naming convention. So, these might lead to a noisy data. Some of the other data problems which require data cleaning are, say, duplicating records, incomplete data and inconsistent data. So, having got some of the noisy data, what are the effective strategies by which we handle these noisy data? The method by where we can handle noisy data, the first method would be on a binning method, where we tend to first sort data and partition into bins. Either it could be equi-depth bins or equi-width bins. So, by way of keeping several bins, we can either cut or partition the data into equal values. Then one can smooth by bin means, smooth by mid-median or smooth by bin boundaries, etc. Further, you can go also by making a clustering of a data which can detect and remove outliers, and we can go by combined computer and human inspection. This becomes a pure manual approach wherein you can detect suspicious values and check by which are cross checked or cross verified by the human. And one of the other way by where we can reduce the noisy level is on the regression. where we can smooth by fitting the data into regression functions. In short, in this particular session, we have looked at different data mining tasks, and we have also said there are two different data mining tasks. One is predictive data mining and descriptive data mining. As part of it, we have started saying the importance of pre-processing. The application need to be identified, for which all the data which is received from multiple data sources, the input data cannot be processed in the same form. So there needs to be a pre-processing which should happen for all the data which I am trying to retrieve. So as a process of pre-processing, or as a pre-processing, I might have to do data cleansing, data integration, transformation, reduction and discretization. So all these procedures have to be done as part of pre-processing state. But then we have looked at in this particular session on the data cleansing process, whereby we have looked at missing values and noisy data. How are these can be avoided? Say missing values can be avoided by replacement of some words as unnamed, or it should not be null. So we can take out some attributes from other table which is what required, and the missing values can be replaced. So and we can also have noisy data as part of this entire relation. We tend to avoid this noisy data either by binning method or clustering or human inspection. That means we are tending to replace all the values, missing elements, noisy elements, by human intervention and regression models. Thank you.